This is the second mini lecture for section 14.1. Okay, so let's talk about some terminology. When we're talking about an experiment that we want to determine the probability for, an outcome is just one single possible outcome of the experiment. So, for instance, when we were rolling dice, we had 11 outcomes, 2 through 12. So each one of those numbers was a single outcome. Okay. The sample space of an experiment is the set of all the possible outcomes. So if I were to list those for that experiment, then that would just be the set from 2 through 12. Okay, so an event is a subset of outcomes. So it's a group of outcomes. Could be just one outcome, perhaps, or it could be more than one outcome. And if the outcome is in the event E, then X is said to be an outcome favorable to the event E. So again, let me write some of this down below from our experiment. When we were rolling dice, so when rolling 2 dice, we had that the sample space, the set of all the outcomes, which was 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, and we found the probability of the outcome 7. Okay, an example of an event would be, let's say, the event in which we roll at least, let's say, a 9. So we roll at least a 9. So there we would say the event would consist of 9, 10, 11, and 12. These are the 4 outcomes favorable to the event E. Okay, so 9, 10, 11, and 12 are the outcomes that are favorable to the event E. Now, as I note here, there may be different ways of viewing the sample space. And this is an important thing to understand. So for example, when we roll a pair of dice, you can either simply write down the score that we got by adding the 2 dice, or you can write down the number shown on each die. Okay, so the first way, let me just redo it here so we've got it on this slide as well. I'll have to write small. Okay, the first way of looking at it was that. Okay, 2 through 12. And there's nothing wrong with that. Another way of looking at it, though, is to, instead of just writing down the score, we could have written down what each die landed on. Like maybe one die is red and the other is green, so we can tell them apart. We just write down how the red die landed and how the green die landed. So if I were to do that, I could record each possible outcome as a pair of numbers. You know, the red die, comma, the green die. And so I can list them in an ordered way like this. We could get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6, or we could get a 2 and a 1, a 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6, and so on. So let's just fill the rest of these out. We can see there's going to be 36 total. So there's 36 outcomes. Now what you'll find about these is that whereas these outcomes were not equally likely, 7 was the most likely, and 2 and 12 are the least likely. With these 36 outcomes, they're all equally likely. So the first set of outcomes are not all equally likely, they vary. The second set, they are equally likely. So when we compute theoretical probability, this is something we really care about. So remember, theoretical probability is when you don't use an experiment to determine how likely something is. You use some kind of counting beforehand to figure out how likely an outcome or an event is. And when we talk about theoretical probability in here, we're going to assume that the way we're listing the outcomes is so that they're all equally likely. Okay, so when I'm talking about rolling dice, then I don't want to look at the outcomes as just the sum of the two dice, because those are not equally likely. I want to keep track of how each die lands. Those 36 outcomes were equally likely. Okay, so suppose that the n outcomes in the sample space S are all equally likely. Then the theoretical probability of each outcome is 1 over n. So if I take one of those outcomes, xk, its probability is just 1 out of n. There's n possibilities. The probability of one of them happening is just 1 out of n. And then if E is an event in the sample space with m outcomes, so E is a group of m of these, then the probability of E is just m divided by n. So for example, what's the probability of rolling at least an 8 on a single roll of 2 dice? When I ask what's the probability, without talking about an experiment, I just mean theoretical probability. And for that, we want to look at the chart we drew. Okay, we're thinking about rolling at least an 8. That means 8, 9, 10, 11, or 12. And I can circle that on here. So these are the outcomes in which we, make that a bit darker, in which we get an 8 or higher. By the way, when we're looking at this list, you can really see why some things are more likely and some are less. 7's the most likely because there's 1, 2, 3, 4, 5, 6 ways of getting a 7. 2 is very unlikely because there's only one way you could get that. Same for 12. Okay, but 8, 9, 10, 11, or 12. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 ways of getting an 8 or higher. And there are 36 ways total. So the probability of rolling at least an 8 on a single roll of 2 dice, well, it's 15 out of 36. And I could simplify that if I want, but I might as well just leave it like that. In fact, let me spell it out a little more. So the probability of getting at least 8, again, is 15 out of 36. That's because there's that many ways of getting 8 or higher, and there's 36 total equally likely outcomes.